This is R.d.sharma solution class 12 chapter 19. Exercise is 19.25. Indefinite integrals we are talking about. Now we have x cos cube x dx. Now we need to change this cos cube x, otherwise it will be difficult for us to proceed. For that we'll use this formula. Cos 3x is equal to 4 cos cube x minus 3 cos x. So we can find cos cube x from here. Cos cube x will be cos 3x plus 3 cos x and divided by 4. So we have this 1 by 4 as a constant here. Now let's replace it here. So this integration will be formed like this. X, in place of cos cube x, 1 by 4 I am taking outside and writing cos 3x plus 3 cos x inside. And with a dx. We'll deal with this 1 by 4 later. This will be two terms, x into cos 3x, because when you multiply x inside, x cos 3x will be one term and x cos x with a 3. So 3 I am taking outside. So it will be x cos x, the second term. I'll just write x there. So this first will be, I'm applying the formula x integration of cos 3x minus d by dx of x. Then again the integration of cos 3x with respect to dx, and final dx will also be done, means integration will be done. So x, what is cos 3x? It's sine 3x and divided by 3, because you have to differentiate this 3x and then divide also the constant. D by dx of x is 1. Integration of cos 3x will be sine 3x by 3. Then it needs to be integrated again. Sine will be minus cos 3x divided by 3. 3 is already there in the denominator, so it will be cos 3x divided by 9. And this is the first term we have taken. 1 by 4 is already there. Now 3x cos x, that will be the second one. Let's do this x cos x now. X integration of cos x minus integration of d by dx of x, then the integration of cos x and then a dx, and then final dx will be there. X cos x will be sin x minus d by dx of x will be 1, cos x dx will be sin x, and once more integration, so this negative will become positive, it will be cos x, and 3 is already there, so multiply 3. So let me write it here. It will be 3x sin x plus 3 cos x. Okay, we have combined these two. So this is the result of this one is the result of this one, and then a addition. But as I told you, there is 1 by 4 already with us, so multiply everything by negative 1 by 4. So x sin 3x divided by 12 plus cos 3x divided by 9 4s are 36 plus 3x sin x divided by 4 plus 3 cos x divided by 4 plus a constant of integration. This is our final result. So this is how it will be done. Only cos cube x formula is important. Otherwise, rest things are quite easier for you. Now tan inverse under root 1 minus x divided by 1 plus x. First we need to get rid of this inverse and also the under root. So we need certain replacement here, or certain x that can formulate in a good way and easier way. So x equals to cos theta, if we put, we already know the formula 1 minus cos theta and 1 plus cos theta. So I am writing this, the whatever is inside under root. So 1 minus cos theta divided by 1 plus cos theta. 1 minus cos theta will be 2 sine square x theta by 2 or x by 2. 2 cos square theta by 2. Now 2 you can cancel, and this is inside an under root. So this sine square theta by cos square theta will be tan square theta. And when it is inside a under root, this will only be tan theta by 2. Now you already have a tan inverse here. So when you apply tan inverse here, this can get cancelled. So you are just dealing with this theta by 2. But dx is also there. So you need to find out theta, which is cos inverse x, because you will be replacing theta some or the other time. For dx, let's differentiate this. Dx by d theta will be equal to minus sine theta d theta. Dx will be, or negative you can take this side, negative dx will be sine theta d theta. So minus I am taking outside, sine theta d theta. This negative half you can take outside, this negative half, and you need to integrate theta sine theta. It's quite easier for you. Theta sine theta is straightforward. So this will be theta integration of sine theta minus integration of d by d theta of theta, integration of sine theta again, and then the final multiplication of these two will again be integrated. So theta sine theta will be what? Negative cos theta. D theta by theta will be 1. Sine theta will be negative cos theta, and minus minus will become plus. Again cos theta will be integrated, so it will be simply sine theta. So cos theta d theta will be sine theta. And you can now add a constant of integration, but before that, why not to replace this theta by actual x? So theta will be what? This x equals to cos theta, that means theta will be equal to cos inverse x. So it will be cos inverse x, cos theta will be x, so write x here with a negative sign, and then sin theta. Because cos theta is already with us, we know that there is a relationship between sin theta and cos theta. X equals to cos theta, sin square theta plus cos square theta is 1. This sin square theta will be under root 1 minus cos square theta. Cos theta is x, so it will be under root 1 minus x square. So sin theta you can replace by under root 1 minus x square. So I am replacing it right now, plus constant of integration. Now multiply everything by negative half because it was outside. So it will be x cos inverse x divided by 2 minus under root 1 minus x square divided by 2, and constant multiplied by any constant will be constant only, so plus constant of integration. And this is your final result. Now this is very straightforward. If you can just find out this trick of putting x equals to cos theta, and other things will be easier for you, because whole idea is to remove this inverse. Sin inverse under root x by a plus x. Now this question is a good question. Now I will first assume something, then you will realize why I have done this. X equals to a tan square theta. Now how this came into my mind, or how did I put it? This tan square theta will be equal to what? X by a. So this tan theta can be written as under root x by a. Now this is x, so dx by d theta will be what? A. Tan square theta will be 2 tan theta. Tan theta again will be differentiated. It will be sec square theta. So dx will be equal to 2a tan theta sec square theta and d theta. Now this integration will become something like this. Sin inverse under root, what is x? A tan square theta. In the denominator a is already there. In place of x, write a tan square theta again. Now what will be here in the inside the root? A tan square theta, you can take a common, it will be 1 plus tan square theta. And 1 plus tan square theta is simply sec square theta. So you have tan square theta by sec square theta. Tan square theta is sin square theta by cos square theta. Sec square theta is 1 by cos square theta. This gets cancelled. You only get the sin square theta, and it is under root. So only sin theta will come. And sin inverse and sin can be cancelled. Now you realize why we placed x equals to a tan square theta. Now integration will be theta, but you need to have this dx also. And dx will be 2a tan theta sec square theta d theta. So 2 will be outside, or 2a will be outside actually. So tan theta sec square theta d theta. Now can you integrate this? Because if you put tan theta equals to some value or p, sec square theta will come directly. There is a theta also, because if you put, I was just telling tan theta and sec square theta integration is quite easy. But there is a theta also. So we'll take theta as one term and tan theta sec square theta as another term. So the first function will be theta, tan theta sec square theta will be another term. 2a will be dealt later. So theta, I am applying the formula now. Theta integration of tan theta sec square theta minus integration of d by d theta of theta, and then the integration of again tan theta sec square theta d theta, and final d theta will also be done. Final integration will be done. So integration of tan theta sec square theta, as I was indicating you earlier, if you take tan theta equals to say t, this dt by d theta will be equal to sec square theta. So dt will be equal to sec square theta d theta. So this integration will be something like this. It will be simply t and this dt. So this will be simply t square by 2. And t was what? Tan square theta. So you are getting tan square theta divided by 2. So this result will be theta. Here it will be tan square theta by 2 minus this d theta d by d theta of theta will be 1. Tan theta sec square theta, what did it give you? Tan square theta by 2. So 1 by 2 you can just take outside. Tan square theta, how to deal with this? We have a relationship between tan and sec. Now sometimes some of the students would like to write or convert this tan square theta as x by a. Integration of x by a will be simply x square by 2. But it is not the case. This can come to your mind and even my mind, because tan square theta is x by a. Integration of x by a is quite simple. It is x square by 2. A will come outside. But that's not the correct approach. You have to deal with theta altogether and then Later on, you can replace theta by this x by a or tan square theta by x by a somewhere. So this approach is not correct. We have to convert this tan square theta as sec square theta minus 1. What I am trying to suggest is tan square theta is sec square theta minus 1 because sec square theta is 1 plus tan square theta. Now integration of these two will be quite simple. First term will be tan theta and next term will be simply theta. So integration of tan square theta after converting it to sec square theta minus 1 has given us tan theta minus theta. 2a is already there in front of everything. So theta tan square theta by 2 minus half, and we got the result as tan theta minus theta for this term tan square theta. And let's close it. Now multiply it with 2. 2 gets cancelled. So it will be only a. Now what will be theta? Tan theta is under root x by a. So theta will be equal to tan inverse under root x by a. So tan square theta can be directly written or replaced by x by a wherever you have tan square theta. So just write x by a. And theta is already there. It can be written as tan inverse under root x by a. So the first term is done. The second one is negative tan theta and plus theta. What is minus tan theta? Tan theta was under root x by a. So you have to write under root x by a here. A is already multiplied, so I am writing a again. Now theta into a. What is theta? It is tan inverse x by a. So let's write tan inverse x by a again here. Plus constant of integration. Now just cancel a. The final term will be simply x tan inverse under root x by a, and this will be, if you take a square inside, let me do it here. If you take this a square inside, it will be a square x by a gets cancelled, it will be simply under root ax. So minus under root ax plus a into tan inverse under root x by a plus constant of integration, and this is your final result. Now this is a quite tricky question, but the solution is quite easy if you just comprehend that tan square x can be written as x by a, or x can be taken as a tan square theta. X cube sin inverse x square by under root 1 minus x to the power 4. Now take t equals to sin inverse x square. You will see what will be the benefit. First is x square will be equal to sin t. You already have a x cube in the question. So you have a x square now. When you differentiate, it will be 2x dx by dt will be equal to sin t will be cos t. It will be cos t. Now we need only x dx. Now sin t is x square. Sin square plus cos square is 1. So in order to get cos theta, cos square will be equal to under root 1 minus sin square. It will be, see, x to the power 4 will be sin square plus cos square equals to 1. So I was telling that cos will be equal to under root 1 minus x to the power 4. Now in denominator we have this. So since the differentiation has given us cos t, that is why I replace this cos t by under root 1 minus x to the power 4. So cos t, taking out it on the left side, it will be 2x dx by under root 1 minus x to the power 4, and that all is in your question. You just have to write x cube as x square into x. So this x dx divided by under root 1 minus x to the power 4 is whole is simply dt by 2. So you can write a dt here. Just a step ahead. I just tried to show you what I am replacing here. Sin inverse x square will be written as t. So let me do it here only. You know what I am doing, right? You don't have to combine t and x together. Actually, t is sin inverse x square. All other things are dt by 2. So you have to just integrate t dt along with a sin t. You know why this sin t has come, alright? Because it has come from that assumption earlier. So you are integrating t sin t integration of sin t minus d by dt of t integration of sin t dt. So this is t, sin t will be what? It will be negative cos t. D by dt of t will be 1, sin t will be negative cos t. You can just change the sign here, plus cos t, and cos t integration will be sin t plus c. Half is there, multiply everything with half. Now there will be a replacement. You can have this half outside, you can have this half inside, it's up to you. So half, what is t? It was sin inverse x square. Initially we took this. So sin inverse x square. What is cos t? We have seen how this cos t has formed under root 1 minus x to the power 4. So write under root 1 minus x to the power 4 here. And then plus half, sin t was what? It's x square. So x square plus constant of integration. And this is your final result, or you can take half outside, it's up to you. This is the final answer. So this is the way you are going to go about it. Sine inverse x square equals to t is the key here. Okay, otherwise all things are quite evident. Now x square sine inverse x by 1 minus x square to the power 3 by 2. Now we'll apply another approach here. X will be equal to sine theta here. What does it mean? Sine inverse, because if you take sine theta as x, the sine inverse into sine theta, only theta will come. So one theta has come because of sine inverse taken as something. Or you can say sine inverse x equals to theta. Now what is this dx after differentiating this? Because x square was x square I have written as sine square theta. Dx by d theta is cos theta, dx will be cos theta d theta. So x square we have converted to sine square theta, sine inverse x is theta, and dx will be cos theta d theta. But you have a denominator also. What will come in the denominator? X is sine theta, x square will be sine square theta, and 1 minus sine square theta is cos square theta, and there is a power 3 by 2, so 2 will get cancelled. Cos cube theta will come. That is, in place of x square write sine square theta, it will be cos square theta, there is a power 3 by 2, 2 gets cancelled, you have a cos cube theta in the denominator, because it's simply 2 into 3 by 2. So this is cos cube theta. What is the benefit here? This cos theta and 1 cos can be cancelled. Sine square by cos square will be tan square theta, and this will be theta only. So you are going to integrate theta tan square theta, and this question has already been done. But don't worry, we will do it in a separate way or in a different way. This sec square theta is 1 plus tan square theta. In place of tan square theta, we will write sec square theta minus 1. And there is a theta already. So multiply this theta into sec square theta minus theta. So there are two separate integrations we are going to perform here. See, the second term is quite easy. It will be simply theta square by 2. It's just like x dx, x square by 2. So it will be minus theta square by 2. Let me write it here. Plus constant of integration, of course constant will come. So we need to deal with theta sec square theta d theta. So I am doing it here. Theta will take as the first term and sec square theta will be taken as the second term. So it will be theta integration of sec square theta minus integration of d by d theta of sec square theta, and then the integration of a theta. That is theta sec square theta integration will be done again. Okay, I have not written integration, there will be integration. D by d theta of theta will be 1, integration of sec square theta is tan theta only. So theta tan theta, and the integration of tan theta also we know. You know what is that? It's log modulus of sec theta. We only have sin theta and cos theta. So we have to convert tan theta in these terms, because cos theta is under root 1 minus x square. You already know that. X is sin theta, so cos theta will be under root 1 minus x square. Tan theta will be what? Tan theta can be written as sin theta by cos theta minus. Now log modulus of sec theta. See, sin theta, this sec theta is 1 by cos theta. So you can just utilize this negative sign in order to make it as a positive sign. And it will be 1 by sec theta. 1 by sec theta, actually it is cos theta. So you are having theta sin theta by cos theta plus log cos theta. If you take plus, cos theta will come upstairs. So theta sin theta cos theta plus log cos theta is simply under root 1 minus x square, and sec theta is 1 by under root 1 minus x square, because cos theta and sec theta are invert of each other. So theta can be written as what? Now I am changing it here only. Theta is sin inverse x. So let me write sin inverse x. Sin theta is what? It's x. Cos theta is what? Under root 1 minus x square. And this will form, I already explained it to you. It will be log 1 by under root 1 minus x square. And it can go up. See, under root 1 minus x square will be 1 minus x square to the power half. When it goes up, it will be 1 minus x square to the power minus half. And in the log, this minus half will come in front. So it will be half in front and then log and then 1 minus x square. I hope you all got the idea. So let me write it here. Theta square by 2 will just deal just now. Theta is simply sin inverse x. So it will be sin inverse whole square x divided by 2. That you already know. Because theta is sin inverse x, you just have to square it. So sin inverse x whole square by 2 plus constant of integration. Now I am combining all of these together. So it will be x sin inverse x divided by under root 1 minus x square. And the second term will be, this half has come from 1 minus x square under root, okay? If you take log, this root will go up and half will come in front. So that is why half log of 1 minus x square. You can write it as ln because it's log base e. And then we have this sin inverse x by 2 whole square plus constant integration. That is your final result. Now let me show you the actual result. This is a very good question, and in 5 marks it may come. So you need to practice this question and even the earlier question which we just did. So that is how this half has come. I was just explaining you. And x equals to sine theta is important, and tan theta sec theta has to be converted into sine theta cos theta. Otherwise you cannot write tan theta here because only sine is given in the question. Okay, this is all about this exercise. Thank you so much and take care of yourself.